Well, good morning or good afternoon, everybody. We're going to be going over the notes for stoichiometry unit percent composition. So, number one, let's do a definition here. Percent composition, it compares element mass to molar mass of a compound. So this is compares element mass to the molar mass of a compound. For example, H2O. We will find out how heavy the oxygen is compared to the whole molecule. That's what we're looking at. Now, there's only 3 atoms in water, so would that mean that the oxygen is 33% of the mass? I mean, isn't there 1 oxygen out of a total of 3? Would that be, what's wrong with that? Does oxygen weigh the same as hydrogen? No. So since we're doing mass, we got to do it a little bit. So what we need to do is we need to find. Okay, so there's our definition. Let's do number 2. Okay, steps to find composition. To find percent composition. So A is going to be find the molar mass of the compound. What's the molar mass of water? 18. Yeah, I mean, by this point you know that that's 16 for oxygen plus 2. So let me scoot this over a little bit so we can see. So the molar mass for our example there, water. Oh, and let's say, okay, we are trying to find percent oxygen and percent hydrogens in there. And the molar mass is 18 grams per mole of water. And up over there. So there's the first step. We know how heavy that is. Then the next step, we're going to divide the element mass by the compound mass. So divide the element mass by the compound's mass, or its molar mass. Maybe I'll be consistent, by the molar mass. So over here, so let's do oxygen first. How much does oxygen weigh? What's its mass? 16. So oxygen is 16 grams per mole. We're going to divide it by the molar mass of water. We said was 18. Okay, let me do 18 grams per mole oxygen. Divide by 16 grams per mole water. So get your calculators out, everybody. What is 16 divided by 18? And you probably got something like, oh, we can't quite see to my light there. Let's see, 0.8888. So we'll go to 2 decimal places. I recommend always go to 2 decimal places. So 0.89 equals 0.89. What does that become for a decimal? What is 0.89? How many? Oh, excuse me. What percent is that decimal? So that becomes, it's 89% oxygen. So now at this point, you should know what's the percentage of hydrogen got to be. It's going to have to be 11, right? Because these two have to all add up to 100%. But we'll just double. Now, here's where you make sure you're careful. How many grams of hydrogen do we have? We're looking for hydrogen. How many grams of hydrogen do we have?
2.
You know, every hydrogen is 1, but we have H2. We have 2 of them. So we'll say that there's 2 grams hydrogen in the molecule and 18 grams of water. 18 grams of water, grams per mole of water. So that should have been grams per mole H2O. What is 2 divided by 18? I know, it's going to be 11, right? Let's just make sure. 2 divided by 18 comes out to be 0.11, which is how many percent? 11% hydrogen. So that's how you would do these problems. I guess part C, if there was a part C, would be convert decimal into percent by multiplying by 100. But most of you know that already. So that's the notes for that. Our first problem is going to be, we slide that up in case you're still doing that. Let's find the percent of potassium, manganese, and oxygen in potassium manganese oxide. And so to get the note, this problem, we got the first part set up. Now they've rounded this off to, they haven't rounded it off. Potassium, well, let's find the molar mass. How heavy is potassium? Okay, 39. How about manganese? Manganese is right in the middle of the transition metals here. Take a look on your tables. What is it? Rounds to 55, so we got plus 55. And then we've got, how much is oxygen? And there's 4 of them, so 16 times 4 is 64. Okay, we can agree. So plus, that equals 64. So what's 64 plus 55 plus 39? And no surprise, it comes out to be 158 grams per mole. And in the first part of the problem was set up, okay, that's how they got that 158. So to figure out the percent, you said potassium was 39 grams per mole divided by 158 grams per mole. So what's 39 divided by 158? Did you get about, when we round it to 2 decimal places, 0.25? So this will be 0.25, which will be how many percent? 25%. Manganese, not magnesium, but manganese, 55 grams per mole, divided by, the molar mass was 158 grams per mole. So 55 divided by 158. What did you all get out there? I heard it once. Anybody else? Did you get like 0.348? We'll round it to 0.35. That becomes 35%. Okay, so let's make a prediction. 35 plus 25 is 60. So this one's oxygen is probably going to be 40%. It should. Let's see if we're right. Now, this is where you got to be careful. For oxygen, see, this was potassium, this was manganese. For oxygen, we got to remember we've got 4 oxygens, so its weight in that compound is going to be 64 grams per mole of that, and the 158 grams per mole in the whole compound. So those cancel. 64 divided by 158. 64 divided by 158 equals, oh, duh, did I get that right there? 0.40, 40%. Does that all add up to 100?
Yes.
Okay. Oh, yeah, because I added those up. That added up to, yeah, so 40. So that we're doing good. So that's how you would find the percent by mass of each of those compounds in there. Start by find the total mass of the whole compound. Then you just divide each element by total mass. Being careful, if you have 4 oxygens, you got to have the weight of 4 oxygens up there. So I'll have you work on the rest of those right now.